thank you everyone for showing up. And I really appreciate having you guys over here with my very first webinar on machine learning. Now we'll get started with a little introduction about myself. I'm Joe, and I have a degree in computer science. And also I have worked as a coach coder at Google Digital Garage. And right now I am a software developer at Allstate, Northern Ireland. And also as well, I have studied artificial intelligence and machine learning at university. And ever since, I have been stuck to those two terms, artificial intelligence and machine learning. Now, I want to let you guys know that this will be just like scratching the surface about machine learning, because there's a lot of stuff and I could not really cover everything within 1 hour as well. And just will be around the basics. So now we will be talking about what is machine learning, artificial intelligence, and how is machine learning being used in many different industries today. And also as well, we'll have a look to the future of AI and also jobs within machine learning field, and some of the technologies that are used within machine learning area. And then at the end of the presentation, then we will have a slot for questions, as if you guys would have any questions. Now, starting. Now, well, what is machine learning? So basically, machine learning is the science of getting computers to learn by giving them data, right? So basically, you give them data and then they will learn from it. So there are many different types of definitions about what is machine learning, but I have put two of definitions from well-known places. So one would be NVIDIA, and the other one would be Stanford University. So NVIDIA believes that basically machine learning is using algorithm to analyze the data, learn from it, and then make predictions about something in the world, right? And then Stanford is basically the science of getting computers to act without being fully programmed. Yeah, and those are two of different ways how you can actually see it at machine learning. But in general, they all basically mean the same thing. And now going forward, I would like to well, give you just a bit of an idea of how it is being used today. So if you have Netflix and you have watched something like a movie or a series or something like that, and the next time whenever you go to Netflix, you will see something similar to what you see now on the screen. Some basically recommendations about what to watch next based on what you have watched previously. Yeah. So whenever you see those things, right, most likely it's the work of an machine learning algorithm. Yeah, just getting recommendations for yourself. Now, to best understand machine learning, right, let's talk about a bit about artificial intelligence. Because as you can see from my graph, deep learning is a branch of machine learning, which in turn is a branch of artificial intelligence. And that extends to cover many things, right? So going to machine learning, we'll be talking about supervised, unsupervised, and reinforcement learning, parts of machine learning. And then within deep learning, we will just touch a bit about neural networks and basically slightly how it works. Then jumping forward to supervised learning, basically the name kind of says it all, is supervised learning with the aid of someone in this case. So in this case, it's like as if there's a teacher to teach the computer how to learn, right? In this scenario, what happens is that the computer will be given data, and also will be given what type of data I should give back as a result. So in this case, we have a model, right? Models are basically what we call a system that does prediction and all of those kind of stuff. So over here we have a model. Now we teaching model, we give the data to the model. The data will be strawberry in this case. And then besides giving the data, we also tell the computer that this is a strawberry. Yeah. And then computer will get that and computer will know, okay, this is a strawberry. So next time, whenever someone else shows a strawberry to the computer, yeah, computer will tell that person that this is a strawberry, just straightforward. And computer knows that because computer was told that that was strawberry, along with showing the data about what strawberry looks like. So usually the goal of supervised learning is to get computer to be so good at knowing about data that it will be able to predict the output when you show it new information, new data set. Yeah. And another thing is all that is a bit of common sense is that usually we learn faster when we have someone teaching us. Yeah, when we have a guide, if you will. And this case is no different. So you see machine learnings, they learn faster when there's a teacher. And for that reason, supervised learning is more commonly used in real life tasks. So a few examples of what it is used for today. So we use it for spam filtering. It's basically whenever, every day we get loads and loads of emails, right? So now deciding which email is spam and which is not would be a rule of machine learning. They can decide that really precisely in a way that you don't get as many spam emails to your inbox. And also along with that, we have language detection as well and search of similar documents and sentiment analysis. A sentiment analysis is quite famous in certain areas. But what it can do for you, say if you have a social media account and you have basically 100 or 1,000 of people commented on your post or interact with your post, right? Then you can use sentiment analysis, which will in turn read all of those comments and then tell you out of those comments which ones are positive, which ones are negative, and which ones are neutral. And then they do that because they know what to look for whenever they're looking for positive, neutral, and negative comments. That makes sense. And then we also have recognition of handwritten characters and numbers. And also we have for fraud detection. So machine learning is really strong in these areas, and it's basically changing everything in these terms because they can do certain things so much better than we human can do. And also, I decided to also put in some of the known algorithms that are used quite a lot within supervised machine learning. We have quite a few of them, and this one is just a few of them. And I will be talking a bit about decision tree. Well, not even talking, just giving an example. A decision tree can get really quite complex. For instance, say a good example of decision tree would be, for instance, at nighttime, you feel like you want to go to bed, right? So that's the question you ask yourself, okay, should I go to bed? Then the answer would be either yes or no. So if the answer is yes, then you go to bed. And then whenever you go to bed and your room, you ask yourself, should I leave the light on or put it off? Then the answer would be either yes or no. And then if you reply yes to that, then the next question can be, okay, if the lights stay on, will my bill increase? Then you have again, yes or no. But then I feel like many other people, then probably you'll say no to that question because they want bill to increase. Then if you say no, then you go back again to turning the light off, right? So you then turn the light off. And then whenever you turn the light off, then you can have even more questions like, okay, now I'm in bed, ready to sleep. Now, should I do a sleeping exercise? Yes or no. So it can get really, really complex. And many people and companies use that to troubleshoot plenty of systems as well. And now onto unsupervised learning. Basically, it's quite like supervised learning, but in this case, we don't have a teacher. We don't have a mentor, someone to tell the machine what the things are. So then machines now are supposed to find it by themselves. Yeah. So in this case, just the data is given to computer, so it's not told what it needs to give out. And also, it is really good to use when you want to learn more about certain data. So it will find structure in data that will then allow you to better understand it, if it makes sense. So then, few examples of how it is used nowadays. So it's used for market segmentation. For instance, say if we're talking about types of customers, yeah, and then if you have a company, then many different types of customers buy from your shop, right? And now you want to know basically what you can do with that information. If you run unsupervised learning, what it can do for you, it can separate the data into different groups, as you can see over here, and then those groups then will be different types of customers. For instance, this group could be a normal type of customers, over here would be a premium type, over here would be VIP type. So it allows you to see a lot of your basically a lot of data in a way that you would not necessarily be able to do if you did not have the model helping you. And also as well quite useful for image compression as well, and to analyze and label new data. So sometimes some people, they tend to use both. For instance, if you're trying to use supervised learning, right, you have it labeled data. So you know what it is, you are able to tell the computer what it is because it's labeled, right? So whenever you have a data that's not labeled, then you want it to get labeled. So you can use unsupervised to get labeled. And then after, whenever you have it labeled, then you can give it to supervised algorithm, and then they can then go about on giving you the output that you are looking for. That makes sense. And also another thing as well is to detect abnormal behavior is used quite a lot on that sense as well. Another thing that I wanted to talk as well is algorithm. So I mentioned algorithm, I think 1 or 2 times, if not a bit more. So basically, algorithm, well, I'm saying this because back in the days when I started with computer science, and whenever someone said the word algorithm to me, I kind of felt a bit lost. I was like, algorithm, what are you talking about? But then actual algorithm is just a set of rules. So a basic set of rules to do a task. For instance, say if you have a robot, yeah, and you want it to drive a car. So what you'll do then, you'll give a set of rules on how to drive a car. So basically, turn the car on and accelerate, turn the wheel around, and all this kind of stuff. So those would be set of rules to achieve on driving a car. So that would be basically what algorithm would be. Yeah, just wanted to get that out of the way. And also, as well, since I talked about some algorithm from supervised learning, I thought it would be fair to talk about some of them from unsupervised learning as well. So we have, one of the most famous is K-means clustering. Probably you have heard about that one before. Basically, it works in a way by partitioning data into different portions and then working with that on that way. It is a lot more than just that. It's quite useful for many different objectives. Now, if you want to know a bit more about all of those algorithms, I will recommend going up and looking them up, because they are, although unsupervised learning, some people believe that is not really the best way to go on things, right? It still is quite useful. Yeah. And then now just a big overview, just to make sure that I'm not speaking gibberish and you guys are understanding what I'm trying to tell you. So basically over how we have an example of supervised learning. We have a model, and then we have a data that will then input the data into the model. And then with supervised learning, we also tell the model what the data is. For instance, now we tell the model that these are apples. Now the model will know that these ones are apple. So whenever you try to give the model a new item and ask the model to tell you what it is, it will tell you it is an apple because it knows what apples look like. Yeah. But now if you have this model, right, this model is not trained on knowing out what apples are, right? If you give, for instance, a banana to this model, it will tell you that it doesn't know what it is because you never told it what a banana is. Yeah. And then unsupervised learning is pretty much the same, but the difference is that you don't give it the annotation. You don't tell it what it is. You just get the data and give it to him, and then now let it do whatever it wants with the data. And then after, whenever it gets the data, it will analyze the data and then put the data out in pattern in a group. We'll organize it in different type of groups. So over here we have apples and looks like tomato and bananas, right? So now it found out that those are different, and they put the different ones together, and ones that, well, I mean, different ones, for instance, all the apples together from a banana set, which are different. So they really good at doing that and categorizing the data. And also as well, another thing is all to say is that supervised learning model usually just predicts the data. You give it the data and it'll predict the data for you. Yeah. And now fast forward, we have the reinforcement learning. This one here is one of, how can I say, one of the most thrilling ways of learning out there, because it's kind of like just how we would really teach our kids, if you will. For instance, we have an agent, and then we place the agent into an environment, and then the agent will do something in that environment. And then if the thing that the agent is doing is wrong, we'll then punish the agent so that the agent will not do that again. But if the thing the agent is doing is right, we will then give it a reward. So then it will try to repeat the same action again. So basically, a core idea of reinforcement learning is surviving in an environment. For instance, whenever you put an agent in that environment, if it does something bad, it will get punished. Oftentimes, those punishments is destructions of those agents. The next agent will come in and will know that and will try to not do that mistake again. And over time, you'll find out that after a while, those agents, they will be quite good at doing good things and getting rewards than doing bad things and getting punishment. So basically, thanks to reinforcement learning, we are able to let a self-driving car learn how to drive on virtual city. Another thing that's quite interesting is that this is actually how we train our pilots right now. So you see all these likes of Tesla and other types of models that are driverless car, they kind of go through this process as well. So basically what happens is that we create a virtual city based on a real map, and then populate the city like with objects and things that we would find in real life scenario, and then let the car learn how to drive safely through the city. So then after a while, after several hours of driving safely within the city, then the robot will be reviewed. And then again, if the robot is somehow confident in the artificial environment, then what will happen next is taking the robot out of the virtual environment and putting it within the real environment. And then there's another thing as well with that, with self-driving cars, because usually sometimes it crashes, yeah, and then people start thinking, oh, it crashes, is that reliable, and all this kind of stuff. But I think a good way of seeing it is that those cars, they learn in a virtual environment, yeah, and the scenarios, most of the scenarios are almost as accurate as cars would find in real life scenario. But then there's some scenarios that the car will not necessarily find within the learning environment. For instance, if a car is driving on the rocky area and then the rocks just start falling down, right? That car probably never had that experience in the learning environment. So then what the car will do facing that situation, then they will try to find a way to get out of that situation in the best way possible. And I'll speak slightly bit more about that with those two approaches that I'm about to talk about. And the approaches within reinforcement learning are model-based or model-free. Model-based means that the car will need to memorize a map or part of the map, right? But this approach is now very outdated because, say for instance, if a car has memorized a map of the country, yeah? And now let's assume that the car now goes to a different country, right? Then the car might as well be useless because it doesn't have information about those maps, so those sites, so it will not be able to drive on that area. Now the other one is model-free free learning, which means that the car does not memorize every movement, but it'll try to generalize situations and act rationally while obtaining maximum reward. So whenever, say, if a car is driving on the rocky area and then rocks start falling down, then what the car will do, it will try to generalize that situation to something that it learned while training, and then try to get the maximum reward by trying to get acting in a way that it thinks it will get out of the rocks without crashing the car. But oftentimes, the decision that the car takes is not really the best decision, if that makes sense, and then end up kind of causing a bigger accident than what it would be. But then these situations are extremely rare, so rare that that's why we don't really often find them on a training environment. Now, we have now neural networks and deep learning. So basically now we are going into deep learning side of machine learning. So basically neural networks within deep learning is an approach that humans try to kind of get computers to act based on the animal brain. So basically, the way how animals learn things is basically how they are trying to get computer to learn as well. And then it's actually through a collection of many neurons and connections between them. So something quite interesting about neurons is that neuron is a function of with multiple inputs and a single output. So if we have a look at this graph, we have the input layers. So over would be all the inputs. We have 4 inputs. We can have quite a lot of inputs. And then in the middle, we have a hidden layer. So the hidden layer, we only have one hidden layer over here, but we can have multiple hidden layers. And then at the end, we have the output. But then the thing with this approach, right, is that the more hidden layer you have, the better output you'll get. Yeah, and also as well, it is extremely good, and so good that it can solve many of the extremely complex problems as well. And it's used quite a lot as well in many different areas. So another one as well within deep learning is convolutional neural networks, or CNN. I'm fairly sure you guys have seen this type of image before, where you have an image and then you have these tiny little squares, a rectangle showing whether it is a car, traffic light, a person, a bicycle, just trying to detect the object within the image. And that's actually the work of CNN, and it works within images and videos usually, and is really, really, really good at recognizing objects. So as you can see from the slide, it's great at doing the facial recognition. And also as well, if you have, say, a photo of an animal, right? And you want computer to tell you what it is. Then you present that image to the computer, and then the computer will tell you what it is. And then whenever that happens, this is what the convolutional neural network is what will kind of be allowing this process to happen. And then now we have the timeline. Usually what happens with timeline is that people have timeline at the start of the presentations, talking about artificial intelligence and things like that. This is a slightly different type of timeline, just to get you to understand the concept a bit more, and then actually as well see what is going on in the world regarding artificial intelligence at the moment. So what it has been around since 1950s. I think artificial intelligence was actually founded in 1956, if I'm correct. Now, so starting our timeline, we have on 1950, we have the Turing test created by Alan Turing. Basically, his concept was that if a computer, right, can make you think that they are human, then that means that the computer is thinking, right? So basically how it works is that you have a human and you have a computer, and then both of them will then interact through text, well, just through typing, no voice, nothing, just typing back and forth. And if at some stage then the human gets asked who they think they're talking with, and then if they say that they're talking with a human, then that means that the machine passed the test. Otherwise, then the machine fails the test. But then before the test starts, the human will know that they probably will be speaking to another human or to a machine. So then that's a bit more kind of to get them thinking whether it's a human or not. And then even a bit more with this type of testing, I think around 2014, there is a bot by the name Eugene, I believe. There has been claims that that bot passed the test, but then again, many still believe that the bot did not really pass the test. And it's kind of one of those things. And then 1997, there is the Deep Blue as well system, right, if you will. It was created to play chess, and it became so good that it beat a chess grandmaster in 1997. So that whenever that happened, there was a big opening eye as well. And then fast and forward, we have 2005, Honda's Asimo robot. Well, that robot has been around for a while back already, but by 2005 was when they announced new capabilities for the robot. So actually now the robot was able to serve trays as if working in a restaurant. So the robot was able to do a few more physical movements that can be quite challenging for robots to carry out. And then fast forward, we have the 2016 AlphaGo. Well, it was developed before 2016, but 2016 was when AlphaGo beat the world champion in Go board game. And Go is actually a really complicated game. I think it's an ancient Chinese game, and it is really, really quite hard to get a computer to learn that game and to play that game as well. But still, a computer beat a world champion playing that game. Well, that happened because if you remember the way how I talked about self-learning car, learning on the virtual environment. So what happens is that this bot played on virtual environments against itself for so many times, several times, that it became so good that it now can beat world-class Go players. You know, another one that might be new to some people would be Google Plex, has been announced by 2018. Basically, what it allows you to do, say for instance, if you want to go to a restaurant, but if you don't feel like calling to a restaurant and doing a reservation, what you can do, you can just ask the device to book your restaurant for you, and then the device will call the restaurant and get everything booked, and you don't have to do anything. And all of that machine learning and artificial intelligence in works, and it goes way beyond that, not just over here. These are just some points that I just wanted to touch in, and also as well to see from where it kind of started spiking in the past and where we are now. It's just kind of amazing seeing it going forward. And now as well, how machine learning is being used in many different industries. So over here, I have found a plenty of different type of industries just to give you an idea of how it is being used. So now I've talked about healthcare. So basically now there are autonomous surgical robots. So those robots carry out surgeries without the help of a human. So that helps to reduce the human error and then making surgeries even more successful. And also so we have automatic disease identification and diagnosis. So basically is using machine learning to find diseases and diagnose them. So basically, if there is a situation where there's a patient that shows in the hospital and has symptoms, but no one knows what they have and things like that, and machine learning can be applied to find out whether that person has anything. And also so another good thing about this implementation of machine learning within healthcare is that it has been helping healthcare a lot, and the improvements are massive. And also so another thing as well would be virtual doctors as well. So those doctors are basically bots that have been extremely trained within healthcare sector. So they know quite a lot around that area. So much so that whenever you ask it a query or any questions or anything, then they will most of the times be able to tell you exactly what the problem you might be facing. And then again, as I said, I got quite a lot of them. So then now I'll be touching about the gaming area. So nowadays you'll find AI coaching people, and also as well, machine learning is helping improving visual qualities. Nowadays you see new games, they have really, really good qualities. That's thanks to machine learning. And also as well, if you remember whenever we talked about AlphaGo and the other one is all yeah, just went through the slide. That was a really bad thing to do, but then again, yeah, good glimpse. So then, yeah, AlphaGo and Deep Blue there, yeah, just had it blank there. So then, if you remember about those two, they were systems that were trained on those games to beat players on that area. Although those are not the only ones that have been created. There are a lot of them around. And another thing is, if you played games such as League of Legends or Dota 2 or games like that, you'll find out that there are bots as well that are being trained on those games and beating professional players. They can do that because they can learn so well by repeating that learning by so many times that whenever they come to real world to play against professional players, they just have the upper hand all day. So then the last set I have are still showing some of the other industries as well. The AI machine learning is being used in. This one here I'll be touching in entertainment. So many devices, many music devices, whenever you use it to listen to music, you will oftentimes get music suggestions. And that that often is the work of machine learning, basically based on what you have listened and based on what you like. And then another one as well is automatic music creation. On the internet, I have seen plenty of people are talking about how good the automatic music creation is. Basically, what it does, it will just create music based on your liking, your genre, type of music, and all of those type of things. And this is basically just an example of machine learning being used in the real world. And there are a lot more than these examples. As I say, this is just scratching the surface. And also, going forward, I would like to touch about the future of AI. So I think in some places you can quite see some of the things that I'm about to mention. So there is the cyborg technology. Basically, is replacing human body parts by machine body parts. And well, it has done quite a lot now, but whenever we say AI part of it is what sometimes is missing, because we can replace the limb, right? But then we say if we use machine learning to do that, then machine learning then will help you to replace the limb and use your hand as if you had a normal hand. That's where the AI part will be falling into. And then there are really good progresses towards that, and you'll find plenty of information, plenty of news about different types of devices like that on the internet. And that's as well another good thing as well that I like a lot, and I see a lot of news about this area is taking over dangerous jobs. And well, I like this one a lot because I remember when I was working in a building, and then the fire alarm went off, and then firefighters, they came in, and then they just dashed into the building. And I was outside, I was frightened because I was thinking, okay, those guys just dashed into the building. What if everything just blows up? That's them done. But then again, machine learning can help that by creating systems that are smart enough to try to put the fire off whenever they are deployed. So then it takes off the need of human to run inside of building. Well, this technology is still in production, but still there are some places that you can find those things happening already. And also as well, another one will be solving climate changes. So if you remember when they spoke about neural networks and all of those type of technologies within artificial intelligence, so they are really able to solve really complex problems. So then solving climate change as well is something as well that has been proven to be quite difficult. But then again, with help of those devices, or those systems, then we might just be able to solve that. Well, I wouldn't say for good, but kind of do a good number on that as well. And then the other one is one that I find a bit well, interesting and curious as well at the same time, is robots as companions. I have seen people nowadays there are this AI dog that you can buy, and then you just use it as if it's your pet. But it's an AI, and also as well that I think some country in Asia, they have robots that you can actually buy and interact with it in your daily life, just like a companion. And the robot as well is designed in such a way to try to show emotion towards the person. But then again, I remember when I was having a talk with my teacher at university, I was talking about that, and then the question came up, okay, so these robots are trying to show to the human that they have some emotion, right? But then again, are those actual real emotion, or those just something that we just program the robot to kind of behave and show to the human? So then does the robot actually really care for the person, or is just kind of something that was just a program? Then again, talking about that, then can get into gray area and plenty of things. And Also, if you're interested in knowing a lot more about this, there are plenty of information online that you can find. Now, another good one as well is exploring new frontiers. For instance, now the idea of going to Mars has been around for quite a while now. So this one here is quite good in the sense that it allows us to create systems, say, for instance, robots that can fix themselves without the help of a human. So then whenever we are able to, well, now we are able to do that. So whenever we are able to kind of create the best set of those type of robots, then what will happen is that we will be able to basically send those robots basically everywhere, and they will be so good that regardless whatever happened to them, they will be able to fix themselves back and then just keep the mission. Well, you'll find some of those in NASA, but then again, still is a work in progress, although there are some really good models already. And then another big thing as well with another big thing as well about the machine learning and AI is predicting the future. So this is actually one of the big reasons why I wanted to follow machine learning so much, because I don't know, if you like myself, you kind of have that need of being able to know kind of the future in a way that, well, you just stop worrying, if that makes sense. So then, nowadays, plenty of people use machine learning to predict the future, and is really, really good in doing that, although it can get better at predicting the future. And we will be seeing a lot more of that going forward as well. And then as well, as I said, as well, talking about jobs within machine learning field, it's just kind of touching bases really. So now we have machine learning engineer, robotics engineer, computer vision engineer, and data scientist. But I think with this is that whenever you, if you happen to be looking for a job, yeah, what you'll find most often is that some companies, they have the names that they have is sometimes totally different from what you would expect it to be. But then at the end of the day, it means exactly what you have been thinking. Yeah. So and just thought on that. And also, some of the technologies are used within machine learning field. Over here, you can see some of the technologies. Well, some of them are more used than others, but then they all can work together to create really, really good systems. And as well, just going to mention about Python as well, is extremely, extremely good within machine learning, and has been seeing a really big rise in the past few years. And another thing as well, it would be R for the data scientists as well, is really, really good and easy to use programming language on that side. And then also as well, another thing that I want to talk about would be cloud platforms. So if you remember, whenever I said about creating an virtual environment and then having cars learning within those virtual environments, you can achieve that if you use a cloud platform. Well, you can achieve that without a cloud platform, but if you use a cloud platform, then that means that your computer will not the whole application will not require a lot of processing power from your computer. So then things don't crash if you don't have a really, really good computer capable enough to deliver the project. And another thing as well that I would like to talk is about the big data or big data. I'm quite sure many of you have heard about this term before. So basically, apologies about that. So basically, machine learning, artificial intelligence, they learn with the data. Yeah. So then, having that in mind, then it's easy to see that the best data that you can give to the system, the better it will get. Yeah. And big data tools can help you to kind of mine and get some really good data and then use it within the field. Now, another thing as well that has been happening, I think there were a few companies, I don't know if they were startups, they were working in the concept of creating this platform where they can gather the best set of data and sell those data to companies that will then be able to make profit from them. And that's also a really good thing to do. And then again, I think when I flip my slide all the way to the end, I think you have seen this image. So basically, if I told you that I went back in time to New York City in 1900 and took this photo with my phone and came back to 2020 and I'm showing this photo to you, you probably would believe me, right? Well, I think some people would, but some would be a bit confused. So basically, this is actually a photo, as it says, taken in 1900 and has been painted using machine learning, deep learning model. And if you look at it, it looks quite realistic. It looks really, really good. And when I first saw it, it was kind of like breathtaking, really. And then, well, having said all that, I hope you have gotten a better grasp about machine learning, artificial intelligence, and how it is being used in the world and what it can do for future and all that. But then there's also another thing that is really, really very gray area whenever we're talking about machine learning is basically this saying that computer will take over the world. And that saying, well, some people are well scared of it, and some people don't really care about it too much. Well, so to me, a way of saying it, right? So it will say, if you see the robot from Honda, Sismo, right? Imagine if a robot like that was working at a restaurant serving tables, right? Then if you walk up to that robot and then kick the robot, punch the robot, offend the robot, and worst way possible, yeah? And then go sit down, expecting and waiting for the robot to serve your table. What will happen next is that the robot will just come back kindly and serve your table as if nothing happened. But if now we change the robot and put the person, right? If there's a person, a waitress, right? And then you go and punch, kick, and offend the waitress, yeah? And then go to your table and sit on the table and expect the waitress to bring food to your table, yeah? Well, the waitress might bring the food to your table, but then they will be feeling negative about you. But then robots, they are not able to do that. So unless, or I mean, until they find a way, or until they get to be able to feel negative about a person that has mistreated them, then I don't think they will ever have a motive to try and take over the world. But then there are, speaking that, there still are some of another great areas as well with that. Is basically, imagine if there were to happen a big war now, right, between one of two greatest nations in the world, and then if they just think about using robots as soldiers, yeah, so instead of deploying people, then they will deploy machines to fight. Then what will happen is that those machines can be really quite good at killing their enemies. And then if it's wrongly used, then it could kind of go a bit gray. But then again, this is really, really, really narrow and thin and kind of a thing that is really hard to see happening, really. And yeah, so those are things that I wanted to touch on. And well, thank you very much. And also feel free to contact me on LinkedIn for further discussion if you wish. And also questions if you have any. That's it.
Thank you very much, Joel. If anybody has some questions, just remember to unmute yourself. While people are working that out, I just want to say thank you, Joel. That was very informative, very useful. Sometimes people ask questions through the chat, so I think somebody has. There we go. I just want to understand one thing. Is it true that machine learning we're referring now to nowadays also we are referring nowadays also do learn, like a chess game where computer learns on its own whenever it defeats about the wrong step it took and won't repeat in its future? If so, may I know what the applications for this learning can be applied? I'll leave that one to you, Joel.
Let me see, because I didn't have it. Oh, yeah, that's, yeah. Can see that one now. Yeah. But to understand one thing is, was it machine learning? I lost it. Maybe just game or doing some related fit. Well, yeah, it is, as I was talking about the reinforcement learning. So basically that would be the reward and punishment approach. So say, for instance, if there's a computer or a system or machine model trying to play chess, and if it does some moves that are not beneficial to the computer winning the game, then it will then get punished. And then after that, it will know that that move is not a good move to take. So then next time it will not do that move again. It will try to do something else that will increase the chances of winning the game, if that answers the question. Then another thing as well, what is learning can be applied? Well, as it mentioned, is basically a selfless driving car as well. So for instance, imagine that the car is the player, and then the world is a chessboard, right? So then the car will learn how to drive within the world, within the road. And then if the car does something bad, such as a bad move, then the car will be told that that is not good, and the car will get punishment. So then next time, then the car will do something else, will do something different that will then improve the safety of the car driving on the street. If that makes sense, that's the answer to the question.
Hi, yeah, that's me who answered that, who questioned that. Yeah, that's pretty much answered my question. So is it like we need to tweak the algorithms that we have on this car platform in order to let this car learn in the future, or else they will be embedded in the begin itself? Is something I just want to understand is like, okay, so you have this machine learning algorithm for car driving something. So is it like these algorithms also make sure if some accident happened because of wrong interpretation, and will these automatically on its own without any further changes on its own they will learn and then they will update their database accordingly, or else is it like some manual, means user interference is required? They have to understand what went wrong and then they have to tweak the algorithm again. So is it like some manual intervention is required, or it's automatic?
Well, yeah, that's a really good question. Yeah, so whenever a model is trained and deployed, then it will only know what it has been trained on. For instance, if there's a flaw within the model, if there's something really bad within the model, then what will need to happen, there would need to be a manual intervention to kind of update the model with new version. That would be the same model, the copy of the same model that went back to the training environment and were then trained in this new scenario that happened, that caused the accident. So then whenever the car gets updated with the new model, then what will happen is that the car now will know that this action can cause an accident. So it needs manual intervention. Does answer, yeah?
Yeah. So it means it needs a manual intervention. Yeah. So I'm just thinking, I hear from somewhere in the internet is like these can learn on its own and they can adjust their algorithms on its own. Is that something I'm just trying to understand? So how it is possible or something? Because in the chess game, I heard without you manually make some modifications to the model, it will automatically learns and it will adjust its algorithm. Isn't it true? Or it also requires some manual intervention in the case of chess game that we?
Well, a way, because what machine learning and artificial intelligence, well, we are trying to stretch a lot in a way of kind of say, for instance, we have a system that would be in real world. If something happens, then learn that and then don't let that happen again. So that is a big stretch. But as of now, what usually really happens is, say, for instance, if you have an application, right, and then you get, say, for instance, if there's new features to the application, then what will happen? You have to update the application to get those features. So in that is that those machines that have been trained, then they were already trained on specific sets of scenarios, specific sets of environments. And then they will know to generalize the situation. So whenever something happens and they never trained on that before, then they will try to generalize that to what they think is the closest to what they have encountered in the training. So basically, to get them to learn by themselves as they go along is a big stretch, and there are really some works being done on that area. But as far as it goes, usually a model, once it has been trained, it gets deployed, and after being deployed, then that's it. So to better the model, then you have to kind of bring in more basically updated model. Yeah, because another thing as well, like letting the model learn on its own on the real world, well, can be problematic as well, because machine learning, although is an old field, but is also a new field, if that makes sense. For instance, say, imagine that if a system gets deployed, right, and then it has ability to learn, yeah. So what if it will learn about something that it should not learn? And then by learning that, then it might kind of override what it was trained on the virtual learning environment. Does it make sense?
Yeah, I can understand. It has both pros and cons, but the concept itself is titled as machine learning. I know it's a word, machine learning, so that itself is confusing. So machine learning means machine is learning on its own, is what I presumed. So
Exactly.
that's why.
So
yeah, but it's basically like machine is predicting. It's not learning. So you have a predefined set of data and the model you defined, and according to that model, this algorithm works out, and it will just based on means whatever is the input data that it is coming. So this input data, it will maybe process, and then it will try to map that input data with the existing model, and then it will predict based on that input data. Is it right? Or
well, something like that along those lines. Yeah, prediction is a really good word. But then again, I think that will better help you understand about why the term machine learning is, because, for instance, right, the scenario where you say that if there's a car running on the street and then if it has an accident, yeah, if now you ask, does it learn from it? It learns from it. It will learn, and the next time it will try to do it differently. However, that happens when the car is on the training environment, if that makes sense. That's where the reward and punishment are applied. So then whenever something bad happens, then it will learn from it. So then, for instance, if you leave a car driving on a virtual environment for about, say, full week, yeah, then the car will have come across many different scenarios that you'll find in real life situation. So then whenever you bring the car out and let it run on the streets, then whenever it finds that scenario, then it will know that scenario from training. So then it will know, and then it will know exactly what to do. So then if it comes to a scenario that it never saw within the training, then what it will do, it will try and generalize to what is the closest to what it has seen on the training. Yeah, and then if an accident happens and then changes need to be made, then what will happen is that the model has to go back to training environment to train on the scenario. And then whenever it gets confident about the updated scenario within the world environment, within the virtual world environment, then it gets deployed back into the car, to the system. Does it make sense?
Yeah, that is makes sense. So it's same like even in the rocket science, they might be using machine learning to predict, let's say for moon landing, they might predict the means at what time they have to reduce the speed and etc.
Yeah.
So they're all, we are using this machine learning.
Yeah, that's
Okay.
correct. And then with rocket, then they would have a world where they would try to they would try to create, for instance, a universe. Yeah, and then they try to put Moon and Mars in those places. And then after, whenever they create model, then they will try to get them to land within virtual places. Then whenever the model tells them what is the best way to do so, then they will kind of try to implement that in real life. Does it make sense?
Yeah, that's fine. Thank you very much.
Thank you very much. All good. Any more questions?
Just wanted to say thank you very much for the session. It was very informative. Just have a tiny bit of question on what is a hidden layer? You briefly touched upon it, but I'm not entirely sure what it is.
Okay. So basically, hidden layer is basically whenever you have, so talk about neurons. Yeah, you have neurons. You have multiple input points, and then you have output points. So the hidden layer is where the calculations per se will happen. So where the all the processing will happen. Yeah.
Okay.
So yeah, go ahead. You want to say something?
No.
For instance, like if you have a single hidden layer, yeah, then that means that there will be some process, and then you get some sort of output. But if you add more layers to that, then that means that there will be a lot more processes, and then you get the output. So basically, put like that. Well, a good way to think is you have input part, and then you have output, and then in the middle you have a brain. Yeah. And now what a good analogy would be, now imagine instead of having only one brain, you now have two brains. Yeah. So basically what will happen is that those two brains will kind of work together to provide you the best output. If you have three brains, then we'll try to work even better to provide even better output. Then the problem with that is that the more layer you add, the more complex it can get. And whenever it gets complex, then what might happen next is your computer, if it's not powerful enough, it might crash.
Okay. Yeah. Makes perfect sense. Thank you very much.
You're welcome. Thank you.
I have a question. It might be silly. Is it plausible or possible in the future that two machines who learn from the same neural network make somehow their own language and communicate without the input of human?
Well, that's a really, really good question. And I think there has been reports of that happening in the past. But now about making their own language, that would be a bit I'd say a bit hard to explain, because usually a computer will learn based on what you give the computer and the parameters that you give the computer, right? So if whenever you are creating the computer, the purpose was to work on languages and all of those type of things, then it may be quite possible for them to start talking things that humans would not understand. But then another question would be, okay, so they talk in this different tongue that we never really heard before, right? Now, are they actually really making any sense, or they just kind of like malfunctioning around, if that makes sense?
Yeah, exactly. So there is like a gray field, like, are we allowed to turn them off because are they sentient now or not? But thank you.
Yeah, thank you very much for the question. That's a really good one. more questions.
I think we're done. Once again, thank you very much, Joel. Very informative, very interesting. Very good. All right. Well, we have got the speaker for July lined up already. We don't normally have a meetup in July because we take the July holidays off, but I think this is a very mixed up year. So if we've got a speaker in July, it's going to be on Kubernetes, and I've forgotten the exact details on. It's an implementation detail of Kubernetes. I will hopefully get a bio and talk description in the next couple of days and get that posted up. It's about Kubernetes operators. I knew there was a word I was missing there. So yes, Kubernetes operators and the life cycle of developing them. So that's for July. Other than that, stay safe, folks. Thank you very much for coming. Thank you, Joel. Speak to you soon.
All good. My pleasure. Cheers. Bye.
Yep.